Hello, my name is John Kelly, and this is the Weber Auto YouTube channel. This is the fifth in a series of videos on universal joints, their service, repair, diagnostics, history, and so on. And in this episode, we are going to remove the drive shaft, or a couple of drive shafts from the vehicle, and I will show you how to replace the universal joint the right way without the caveman hammer and chisel method, and how to set them up, reinstall them, center them, set the axial play, make sure that everything is just as it should be before you reinstall it back in the vehicle. So to begin with, I've done a little experiment here. I'm underneath a General Motors product here, and we are looking at the back end of the aluminum drive shaft where it connects to the pinion companion flange. And before you remove any drive shaft, of course, you should mark the relationship of the flange to the drive shaft. So I've got these yellow marks here. I made those marks with a yellow paint marker. A paint marker, if you've never seen one before, is just a tube of paint, and they come in different colors, and then there's sort of a felt tip here on the end that soaks up the paint. You can push in on it and it'll soak up some paint, and then you can make some marks. It works great for writing on automotive components, unlike a wax crayon or a pencil or whatever. I just found some of these on Amazon, eBay. You might be able to find them at a local hardware store also. Okay, so I've made these alignment marks, and the alignment marks, as I said, are there to let you know the orientation of the drive shaft when you removed it. And since it has a cross-style universal joint installed in it, it can actually be installed in two different orientations. We could take this propeller or drive shaft out and rotate it half a turn or 180 degrees and put it back in. And some people would think, well, that doesn't make any difference. Well, it can make a difference. Doesn't necessarily mean it will, but usually it does. And the reason it makes a difference is it affects the lateral runout of the drive shaft. So we all would like to imagine that drive shafts just spin on a perfect circle axis and don't wobble back and forth at all as they drive down the road. But that I've never seen one that is that way. So you need to mark this relationship so that you will put it back where it was, because in the other direction, it could create more runout. Now, out of the factory, they put paint marks on these things. Usually they're orange or some other color paint, but you got to look for it to see the match marks, and they don't always line right up with each other, but they'll be on the same side of the universal joint and the flange. Well, the experiment I've done here is I've put a dial indicator. I've put a magnetic mount dial indicator on the axle housing and a roller tip dial indicator tip on the end of my dial indicator. You don't necessarily need a roller tip, but you don't want just some flat end to a dial indicator, or the dial indicator could be skipping and jumping as you rotate the drive shaft to check for runout. Starrett sells a really nice kit that has a bunch of different tips on it. It's kit number 25R. There's some really wide tips, some real small pointy tips, and so on. The roller tip is not part of that. The roller tip is part number 25W from Starrett. They also sell adapters to go from metric threads to SAE threads, depending on which style of dial indicator you have. So anyway, as you can see, I've got this dial indicator set up with the roller tip, and what I've done is I have rotated the drive shaft and I've measured the runout the way that this drive shaft is currently installed in the vehicle. Now, sometimes out of the factory they get it wrong. And if you've just simply forgotten which way it came out, you forgot to mark it before you remove the drive shaft, that's all right, because it can only go in two ways on this style of pinion companion flange, four different ways on the ones that have the flange yoke and the four bolts, like I showed you in the last episode. On the Toyotas and Fords and Dodges have them, and so on. But you need it'll save you some time if you just simply mark where it was. So the runout that I've measured on this is about 13 thousandths of an inch maximum, the way that it currently is. And I've written that runout with the paint marker. I've marked the high spot, the low spot, and the amount of runout on the drive shaft itself. So let me zoom in here just a little bit so you can see. So lined up, let me rotate it around here. Right here is the low spot. I put the letter L right there. That's the low spot. So that's where I zeroed the dial indicator. And notice that lines up almost perfectly with the pinion companion flange for the low spot, the U-joint bearing cap on the pinion companion flange. And then if I rotate it around again and find the high spot, well, the high spot isn't exactly lined up, but it's pretty close at 13 thousandths of an inch to the opposite bearing cap on the pinion companion flange. And so that means the majority of the runout is in the up and down with the pinion companion flange. And if you've put that drive shaft in the opposite direction, it's either going to make it worse or it's going to make it better. When we put the drive shaft back in, we will measure the runout with the drive shaft installed in both orientations to see which way is better, which sometimes is what you may need to do if you change the U-joint and now you have a vibration. The vibration could have been caused by the excessive runout just because you put the drive shaft in the wrong orientation on the flange itself. All right, for measuring the runout, though, you want to not put your hand on, like I was doing, the drive shaft and rotate it, because that can throw off your reading. Just through flexing the mounting possibly of the dial indicator. Depending on where you mount your dial indicator, it might be on a jack stand or whatever. You don't want to be pulling down or moving the propeller shaft when it normally wouldn't be moving that way. So it's better to block one of the rear tires from rotating if it has an open differential, and rotate the other one with the transmission in neutral, and that will allow the drive shaft to spin by itself. So on this vehicle, that's what I've done. Now, since I'm working by myself, all I've done is taken a piece of 2x4 and stuck in the spoke of a wheel and the brake towards the brake rotor and just wedged it in place. And that way, when I spin the opposite side tire, this tire won't be able to rotate and the wood won't damage the wheel, and that will force the drive shaft to rotate, and then you can take your measurements and find the high spot and the low spot and so on. All right, well, anyway, enough of that. Let's take this drive shaft out. As I said, these hold down straps are not reusable. They form fit and stretch down over the U-joint bearing caps. The bolts are not reusable. In the last episode, I explained that. And so I'm going to have to order some replacement straps for this. We're going to take the rear drive shaft out of this vehicle, which is aluminum, with an external C-clip U-joint, and we'll take the front drive shaft out, which is steel and has plastic injected U-joints, and we will replace them with an internal C-clip U-joint. And then I have a steel drive shaft and a couple other drive shafts that we'll look at, and all the tools to do that. So let me get these drive shafts out of the vehicle, and we will go over to the tools and the press, and we will see how to remove these U-joints without causing any damage to the drive shafts, the yokes, and to reinstall the U-joints properly. All right, when you remove the companion flange hold down straps and bolts and you're ready to remove the drive shaft, we want to be careful not to drop it, not to let it fall on the floor when we take it out. We're going to leave the companion flange with the yellow mark pointing straight down, and we're going to take the drive shaft out of the back of the transfer case without rotating the drive shaft, and then we'll put it back in the same direction or in the same orientation so that we don't rotate the output shaft of the transfer case, because even output shafts have runout. And so we want to make sure that we're putting the slip yoke back on the transfer case output shaft on the same splines. So we'll have to line things up when we go back together. And to do that, we'll just keep everything lined up here. So I'm just going to take a pry bar, very carefully pry out and down, and then just pull straight back out of the transfer case and without rotating, and then we can put it right back where it was. Okay, I've got both drive shafts removed from the General Motors product that we were just under. I've got the aluminum drive shaft right here, and for the rear, and the steel drive shaft from the front. The steel drive shaft has the plastic injected retaining rings rather than snap rings to hold it in place. And I told you in the previous episode that we do not use heat. We don't get the torch out and heat this up and try to melt those and push them out because it will it can cause damage to the propeller shaft. It can leave some of the plastic retainer in the grooves inside the ears. And if you don't get all of that out of there, then it can cause an imbalance to occur. And it's just a dirty, messy thing to do. You do not need a torch to get those out. You just need to use the right tools to remove it. So here is a U-joint that we removed from the opposite end in one of my classes over there. And let me zoom in on this U-joint here. You can see that we just simply sheared off the plastic retainer there, and no smoke, no flames, no heat, no damage to anything, no risk of fire in the shop when we don't need it. And there's just some simple tools I'll show you to press these out real quick and easy. All right, so that's one of the U-joints I'm going to show you how to remove and reinstall. Then I've got a steel drive shaft with external snap rings. I've got the aluminum drive shaft with external snap rings. These are all three of these are General Motors products. And this Toyota drive shaft uses the flange yoke here on the end rather than a slip yoke to bolt right to the companion flange. And it uses external snap rings. But remember, for aluminum drive shafts, you were supposed to use special coated bearing caps and snap rings in the aluminum ears, and in steel drive shafts it doesn't matter. So we'll get to that when we put these back together, but for now let's get ready to remove these U-joints. And to do that, there's some tools that I want to show you that are very handy, and none of them are a hammer and a chisel, as I told you in the first episode I was taught to do. All right, we are going to start with a General Motors tool that has been around for, as far as I can tell, about 70 years. The tool number is J9522-3, and this is a U-joint press adapter. And what this tool will do is it will just simply reach in and allow you to push on the U-joint cross rather than be pushing on the ears or through the ears. under no circumstances do we want to put any stress on the ears of any of these yokes, because we can bend those ears. And so this General Motors tool avoids the ears totally. All we do is put a socket or some sort of a hole, a round hole underneath to capture the lower bearing, and we put this in an arbor press or a hydraulic press and just simply press on the cross. It'll push the U-joint bearing cap either out all the way or most of the way, and then you clamp it in a vise and wiggle it around and pull it out. No hammer, no chisel involved. And then you just simply turn it over and do the other way. So on the General Motors products and any other products that the width of this tool will reach down and hit the cross, that's the tool that you use. And I'll show you using that here in a moment. So that's the GM tool. There's a Ford tool that is very similar. It's U-shaped, just like the GM tool, but it is a little wider. And so if I try to use the GM tool on this Toyota, for example, it doesn't fit. The ear width here on the end of the drive shaft is too wide, and so the Ford version of the tool, for their wider U-joints, allows this tool to come in and press on the opposite ears sideways. We're not going to bend them if we push on them sideways, and push through the bearing cap on the opposite end of the cross, just like we do with the General Motors tool. And that will work on the Toyotas, the Fords, the Dodges, any of the larger ones that the General Motors one won't work on. This tool is an OTC tool that Ford recommends. It's part number 205-086-01. So that's 205-086-01. And what's cool about this Ford tool is many years ago I bought a snap-on ball joint and universal joint press kit. So this press, if you put a universal joint in here and you put one ear against this end and you push on the bearing cap, it'll try to push the one bearing cap out this side, but the problem is it pushes in on the top bearing cap, and if you're not careful, you can push it in so far that it falls out on the inside of the ear, and then you're in trouble. So what this Ford tool allows you to do is use your ball joint press and take out this adapter. There should be a little ball bearing down in there, and you put the Ford tool in its place, and then you don't need a hydraulic press or an arbor press. You've got your ball joint press here. You can put your U-joint in here and press out one bearing cap at a time without doing any damage to the ears or the drive shaft. So I've just shown you a couple of tools. The GM tool is about $40. The OTC tool that Ford recommends is about the same price. You can find them on eBay. You can order them directly through the OTC or Kentmore Tools. But there's another way that you can remove U-joints with this style of tool, and that is to kind of make your own version of this tool. So you could get a piece of metal and bend it over and make one very similar. But let me show you a tool that you might already own if you do any axle work anyway, and that is something called a bridge puller. All right, many of you will be familiar with a bearing splitter like this one from OTC. This is part number 1123, bearing splitter, and they come in different sizes for different size bearings and jobs. Well, have you ever wondered what these holes are? These two holes are in a bearing splitter. Those two holes are for what's called a bridge puller, and once you see what a bridge puller does, you'll really like it. And the bridge puller is an OTC part number 927, and it comes with a bunch of rods in this bar here, OTC 927. And what you do is you take these two bars, or these two rods, and they screw into the bearing splitter. Like that. And put the other one on over here. Okay, so you screw them in by hand there. You run down these upper nuts. There's a washer underneath, a thick washer that will stabilize this bridge. This is the bridge. And then it has a puller shaft that is going to go up the middle here. And then you've got yourself a nice puller. You can clamp the bearing splitter around something and then use the puller shaft here. You hold the shaft still and you turn the nut to push or pull the whatever bearing off that you're doing. Well, this bridge puller it's also called a push puller. It'll also push. And so if you want it to push something, then you take off the bearing splitter. So let me just remove the two pieces out of the bearing splitter. So we'll get rid of the bearing splitter. There are two little feet that come with the push puller, the bridge puller here. And these little feet just screw on in place of that bearing splitter. You're going to run it all the way down as far as it'll go. And now you have a different style of puller. You can take the shaft and bring it down through the top this time instead of the bottom, and you can attach certain things to it and turn this, and it will push down on the two bars here and pull up in the middle. So that's a bridge puller, a push puller. Well, I had the idea of what if we turned this bridge puller into one of these U-joint tools. Where did I put them? Oh, here we are. So we've got a U-shaped General Motors tool. We've got a U-shaped Ford tool. How about turning the bridge puller into a U-shaped tool also? And the width of the pusher arms here is adjustable. So we can adjust this, the width of it, to come in and push on the ears, the side ears of the bearing cross to push the opposite bearing cap out. And if you do that, you've got a nice adjustable U-joint pusher that you just used with a Arbor press or a hydraulic press, and it's a variable width, so it'll fit many different sizes of universal joints. So that's another idea for you to consider. There are all kinds of other special tools out there that I've seen and tried for removing universal joints, but the main thing you want to avoid, and take a look at how you've been replacing U-joints and see if you can state this. The thing you want to avoid is under no circumstances do we want to bend these ears at all, ever. Let me show you some ears that are bent. I have a front solid axle, one of the axle shafts that goes out to the wheel hub, and somebody in one of our classes years ago tried to press out or hammer out or caveman out, whatever whatever you want to call it, a universal joint out of this thing. And I want you to look at these ears right here. Do those ears look like they're spread out? These are almost in the shape of a Y. They've been bent so badly. And if you compare that to the one that hasn't been pressed out at all, you can see that the overall width, let me line up this one side here. it's sticking out quite a bit farther. It's been spread really bad. And why did it get spread? I suspect that somebody clamped it in a vise and started hitting with a hammer, or used something to push in on this one. If you push in on the top U-joint bearing cap and try to push out the bottom one, of course, a common mistake for beginners is they don't pull the snap rings out. That's a problem. You must remove the snap rings. But if you're pushing in on this one, you're putting stress on the upper ear and you're putting stress on the lower ear, but you're putting more stress on the upper ear. If you don't have something to support the lower ear, then you're putting stress on the lower ear and you'll bend it also. And so the method I'm going to show you is we are going to put a plate with a hole in it underneath here, or a socket of the right size, like a lot of you have done, to support the lower ear, so that when we push down, not on the upper bearing, but on the cross itself that's broken off on this one, then the ear has no chance of being bent. And so whatever tool or method you use, you want to avoid having these bent ears. If you go on Spicer's website and look at their diagnostics for their drive shafts and U-joints, these holes here are actually line bored. They're line bored, just like a camshaft bearing set of holes in a cylinder head or an engine block. For the larger U-joints, they actually have a round tool, which I don't have, of the appropriate size, that you're going to put through these ears, the holes in the ears, and see if it slides through easily. On this one, especially if I turn it upside down here, there's quite a gap. These are what are called parallels from Sterita. They're nice, flat, straight pieces of metal. And if these ears were not bent, they would lay perfectly flat on the bottom of those surfaces. But it does not. There's a giant gap over here on this side where this ear is bent. So these are line bored. Remember, U-joints are bearings, and so we must treat them just as carefully as you would a crankshaft bearing, a connecting rod bearing. You don't hammer on them. You don't leave a little dirt in them. You don't allow rust and paint and whatever to stay in the area where they've got to go, because that will affect their useful life, just like it would on any other bearing. All right. Well, let's press out some U-joints. All right. I've removed the other drive shafts because they were in my way for the first demonstration. We are going to remove a U-joint from one of these General Motors drive shafts. Both of these use the same U-joint, other than the coated one in the aluminum. And so we'll just do one of these. Whether it's steel or aluminum, it doesn't matter, other than the snap ring. The snap rings need to be coated and the universal joint is coated. But this steel universal joint has a problem. I want to show you, so let me zoom in a little closer here. Look at this snap ring right here. In the previous episode, I told you that we need to inspect the snap rings to see if they're bowing out. See how the snap ring is bowing out really bad in the center? That's a sign that there's a problem. And if we look at the movement of this slip yoke on the drive shaft, notice that it goes up and down real easy. It just falls down this direction. But if I turn it this direction, notice that it likes to go side to side, but it does not want to fall down. It'll just stick in the one position. And so what we have here if you look closely right here, there's some damage. Somebody has dropped this, or well, actually, I don't think it's been dropped. I think that it has been, somebody's changed the U-joint improperly. It's all beat up right there. And what makes me think that it's been changed improperly is there's a big dent right here in this tube of the drive shaft. So let me turn it sideways there. Can you see that dent right there? That dent usually happens when somebody's clamped this in a vise, and this is pointing down, and then they start pounding the old caveman hammer and chisel method of removing the universal joint, and they've bent the tube, they've damaged the ear of the yoke there to where it's caved in a little bit. The groove that the snap ring has to fit in, and so they've taken a hammer and just kind of pounded it in. Have you ever had to take a hammer and pound a snap ring in? Don't do that. That's a sign that there is something terribly wrong. It's telling you, hey, there's something wrong. On the other side here, there's some damage. It's difficult to see. Let me see if I can get in just a little bit closer here. But this bearing cap has been caved in. It looks like somebody's taken a hammer and punch or chisel or something and tried to push in on this bearing cap. Well, that bearing cap is it rests on the thrust end of the U-joint cross. You start pounding on that, and the thrust washer that's in there to prevent metal on metal wear will be destroyed. And so I'm fairly certain this U-joint is absolutely destroyed. Obviously, there's a problem because it doesn't want to move up and down freely like it should. And it would move up and down freely if it had the proper end play. There's actually going to be a little tiny bit of clearance up to 0.02 of an inch approximately, which is adjustable with different snap ring thicknesses. All right, so let me get this damaged one out of the way, and we'll look at the one that we took out of that General Motors product. Okay, let's look at the snap rings on this universal joint drive shaft. Notice the snap ring here in the aluminum ear is kind of a dark black color, and that's because it's a coated snap ring. If we turn it sideways 90 degrees and look at the snap ring that's in the steel end of the yoke, notice it's a little rusty, and that's because it is not a coated snap ring. And then let's take a look at the free play on this. This vehicle is not having any problems with U-joints, and I want to show you that we've got just free flopping around movement in that direction, and if we turn it this direction, we've got free flopping around movement there also. That's what you want. You want to have nice, loose U-joints. If when you're done, it's binding up in one or both directions, something is wrong. Sometimes it's just that the bearing caps have been pressed in too far, and in that case, you do not get the hammer and the chisel out or the punch. You get your U-joint tool back out, and you come in and you push on the bearing cross or the ears with the larger tool and push the bearing back against the snap ring on both sides, and that should free it up. Now, if you push it too far, then you'll start bowing the snap ring, which this one here actually has a little tiny bit of bow on this side of the U-joint bearing cap. Let me introduce you to the Arbor press. A lot of guys, if you don't use a vise, which you'll see, I don't use a vise in most instances. I just use a press and the proper tools. But right here we have an Arbor press, and this particular Arbor press is made by a company called Dake. That's D-A-K-E. They're right here in the United States, in Grand Haven, Michigan. This is their 1.5 ton Arbor press, and what they have is a shaft that comes down. It has gears on it and a handle that we can push down, and the 1.5 ton portion of this Arbor press allows us, without a hydraulic press that can damage so many things before you realize it, it allows us to put 3,000 pounds of force on whatever we're trying to press in here, either to remove or to install something, by only applying about 95 pounds of force here. It's a 32-to-1 gear reduction between the handle and the shaft here, the geared shaft that comes down. So if you take 3,000 pounds divided by the 32 ratio, I think it's, I don't know, 93, 94 pounds of force that you'll have to put on it to deliver the 3,000 pounds of force. And that's pretty impressive. And the thing I really like about that is you can feel, as you pull on this handle, as you can feel as you're pulling down, if things are going nice and smooth or if things are binding up. You can't feel that in a hydraulic press. Instead, you're just breaking needle bearings and bending yokes in the end of the drive shaft, or damaging the bearing cup. An arbor press is a great way to go. Now, a ball joint press works also. That one I showed you with the threaded end, you just put a wrench on it. Not an impact gun. Do not put an impact gun on that shaft. Even though it's made for it for removing ball joints, it is not intended for removing or especially installing universal joints, because you do not want to let it get away from you and start bending things. So if you don't have an arbor press, look into getting one. I think they're around $1,000, and you might think, well, that's a lot of money for something for U-joints. Well, it's not just for U-joints. Anything you do in a hydraulic press, you can do here, as long as it doesn't require more than 3,000 pounds of force. We have a gauge on our hydraulic press, and rarely do we go over 2,000 pounds of force. And so we have 2 hydraulic presses and 2 arbor presses here in the shop, and we use all 4 of them as necessary. But my absolute favorite by far for any type of automatic or manual drivetrain related pressing is an arbor press. And you can mount it right to a bench, or for another $800 or so, I think they have a stand that mounts to the floor to where it'll become a standalone unit. But it's a great way to go. All right, well, let's remove these snap rings now. I told you in the second episode, where we talked about the differences in snap ring thicknesses, that if I were you, I would remove the snap rings and keep them. I would measure their thicknesses and see, or I'd make a collection of them, because they come in 7 or 8 different thicknesses. And so we're just going to come in with a pair of wider needle nose pliers and attempt to just squish in on the snap ring and get it out. Now this one took a little bit of coaxing. This one is copper colored, so let me zoom in on this so you can see a little better. So this snap ring I've removed is copper colored. Copper is the most common color of snap ring from Spicer, and I believe it is 65 thousandths of an inch thick. Let me look at my board here. No, it's 59 thousandths of an inch. So the copper colored snap ring is 59 thousandths of an inch thick. Now this snap ring is no good. How do I know? It's sprung. If you look, or if you watch my third episode on U-joints about U-joint history, you'll learn about a patent from a guy that first developed this type of a snap ring. And let me put a piece of paper or towel behind it so you can see it a little better. If you look at the little tab there, see how this tab that's horizontal right here sticks out farther than the tab that is vertical? Those two line up perfectly when they're not destroyed, when it's not sprung. They line up perfectly on a new snap ring. And so this snap ring needs to be replaced. This is not one that I would keep for future use. This one's definitely been squozing too hard, and it may have been me. Maybe I squoze too hard just getting it out. The best thing to do is just squeeze it just enough to get it out. But this one was fighting me a little bit because it seemed to be stuck in the groove a little tighter on one side than the other. Now that means the opposite snap ring here should also be copper, because we always want equal thickness snap rings on the same U-joint. fighting me a little. There we go. Okay. Get that one out. I've also ruined this snap ring. Trying to get it out. I've caved it in quite a bit. Not reusable. So, and it was stuck in there pretty well. Okay, so we have 2 copper snap rings. If we were to measure them with a digital caliper, they are, when they're clean, they are supposed to be 59 thousandths of an inch thick. Whoops. Let me zero my caliper here. 59 right on the button on that one, and 58 and a half on that one. So 2 equal snap rings in the steel portion. Now, why am I keeping track of these when I disassemble it? Well, because it'll give you a clue of what might need to happen when you go back together. Now, the U-joint cross width, the width of bearing cap to bearing cap one side versus the width of the other side, ideally should be 0. But as you may have seen in my second episode on comparing U-joints, that isn't always the case. But if it were, the difference would be variances in the yoke itself, where the grooves were ground. And if you just come along and buy some aftermarket U-joint that comes with 1 thickness of snap ring, maybe it'll fit in the grooves on one set of opposite bearings on the cross, but it won't fit in the other groove. Let's see what the thickness of the snap rings are on the opposite grooves here. So these are some coated snap rings now. This one I also squeeze too tight. It doesn't line up. Let's measure the thickness of it right out of the factory. 63 thousandths of an inch. 63. So we had 59 on the 2 others, 63. So we have 4 thousandths thicker. That's 8 thousandths of an inch between the 2 snap rings that is being made up because of the variation in the width of the grooves for the ears. So let's turn this over and measure the other one. We'll get it out and measure it. This one's bowing a little bit, but it came out okay. I've destroyed it also. It's squoze too tight. This one is 63 thousandths of an inch also. So we have 2 59s on the steel portion, 2 63s on the aluminum portion. There's no aftermarket U-joint that comes with, well, I shouldn't say there isn't. I haven't seen an aftermarket U-joint that comes with multiple thickness snap rings. So let's get back to the same question that I've talked to you about in previous videos, is have somebody ask me, well, I've replaced a U-joint, now there's a vibration. It could be but that by you jamming or cramming in the wrong thickness of snap rings in here, you've taken up the lateral play that's supposed to be in the joint. It's seizing up in one direction, maybe not totally seized up in the other direction, so it's binding twice per revolution, which can cause a second order driveshaft speed related vibration. All right, now let's press these bearings out. This is the General Motors drive shaft. So for General Motors, they recommend either a socket or some sort of a plate with a hole in it. This plate here was designed for piston pin removal or pressing back on a pinion bearing on an older vehicle, but just some sort of a round plate. This has a ridge on it that sticks up just a little bit, that is helpful for laying the yoke on. And so we're going to set this on the Arbor press, and then we're going to put the special tool over the U-joint cross, and press it out. All right, now here on the bottom of the arbor plate, there's a press plate that we can remove that has several different thicknesses or several different widths of holes that you can use to push things through. I'm just going to take that off totally, and the reason for that is the widest groove is not wide enough for the bearing cap to fit through. And then I'm going to sit this adapter plate. Now, if I was using a socket, I would just set a socket that's larger than the bearing cap. So find a socket, get your new universal joint, and make sure the socket will fit freely over the joint, but just barely, because it needs to still support the ear of the drive shaft. But these are the official tools for General Motors. So now I'm going to come in and set this on here, just like that. I like to have a table next to the arbor press so that I can put, so I have something to hold the rest of the long drive shaft in place with, and a couple of 2x4s to hold things level while we press. All right, so I've got the hole in the little plate lined up with the hole in the press. This plate could lay across a hydraulic press also, but if you use a hydraulic press, please be careful. We're going to line up the hole of the U-joint and feel underneath, make sure we're centered. Not going to push on the plate itself. And then we're just going to come in with the special tool, set it right here on the bearing cap, bring the arbor shaft down. We're going to scoot the whole thing back just a little bit to where the whole thing is resting, just like that. I'm going to double check my holes underneath. So I've got the plate, I've got the lower ear, I'm pressing on the cross, so we're not touching the upper ear, we're not touching either side ear. We're going to push on the cross that'll push the bearing cap through the lower ear that is fully supported by this plate or by a larger socket. And then we're just going to come in and push down or pull down on the arbor press to push the universal joint cross down. And so down it goes, just like that. I brought it all the way down to where the cross is touching the ear. We do not want to go any farther than that. All right, so now we'll lift up the arbor shaft here a little bit. As you can see, we've pushed down significantly with the tool. The upper trunnion is now visible. And let me lift up on the drive shaft. There's our lower bearing cap right there. And it's not quite out all the way. And so the instructions tell us to clamp this in a vise and hold the bearing cap solid, and then wiggle the drive shaft back and forth to walk the drive shaft off of the bearing cap. And then we'll come back and press the other one out. So let me put that in a vise and get that out, because we can't push the other one out without having this one out first. Okay, so I squoze that I squoze the bearing cup in a vise to hang on to it, and then wiggled the drive shaft back and forth, and took a little pry bar and just kind of pried between the bearing cap and the top of the vise, and it pulled the cap out the rest of the way. So now we're going to push the other direction and push the other one out. So we'll just come in and do the same thing. Double check, make sure everything's lined up. Looks like it is. And with very little effort, we're just going to push that cap down until the cross hits the ear, and I'll lift it up. And we should be able to take the yoke out. The other bearing cup is still in, so we'll have to go to the vise and pull it out. Yeah, looks like it's fighting me a little bit, so I'll go to the vise and pull that one out next, and then we'll get the rest of the bearing out. All right, I've got the other bearing cap out. Now we're just going to rock the U-joint cross up and out of the ears of this aluminum yoke. By the way, I forgot to mention it, but before disassembling a yoke from a drive shaft, you need to put alignment marks on it. So we've got a yellow alignment mark right here that lines up with a yellow alignment mark right here. That way I know it went like this and not like this when we go back together. Now, I know that you're probably just going to throw away the U-joint when you're taking it out, but there's something that you want to look at on the U-joint trunnion, which is the trunnion is this portion here where the needle bearings in the U-joint bearing cap actually ride. You want to look at that to see what condition it's in. You want to look at the thrust surface end, this end here. Look at it. Is it nice and smooth, or is there signs of damage of some sort on there? There's all kinds of problems that can occur. You've probably all seen the little indentations going around the trunnion. That's called brinaling. And brinaling basically is pressing something really hard against this surface. It'll make an indentation in it called brinaling. And that indentation is caused from excessive torque. So we've got a really hard bearing, we've got a hard bearing surface, but those little grooves that you see in a U-joint bearing cross can actually be caused by excessive torque, improper U-joint angles, an angle that's too low to where the bearing doesn't rotate at all. It just sits there and constantly pushes in the same spot the entire time. So that's why we don't want a zero angle. We have to have some movement to prolong the life of it. But if you see that brinaling, it could happen to a future U-joint. And so you want to try to figure out why, especially if you're having repeat failures of a U-joint. If you're seeing the brinaling all the time, that's like taking a hammer and hitting a surface and making a dent in it. It's had a lot of shock load put on it, or a lot of heavy load. Somebody's pulling a trailer or hauling something that has too much weight for the rating of the vehicle. U-joints have a maximum rating of how much torque they can handle, how much load they can handle, and if you overload it, then things are going to start pressing into each other and smashing. So that's something to look for on repeat failures. All right, let me get that U-joint out of the way. Obviously, we're just going to press the next two bearing cups off the same way, and once we do that, and I'll do that off camera here, then we are going to inspect the ears of the drive shaft itself. So we want to look at the ears, we want to look at the inside area, we want to clean all that out. Remember, this is a bearing surface. Just like when you're putting bearings in an engine, you wouldn't leave a bunch of grease and dirt in there and just pop the new one in on top of it. You need to clean all that out. We want to look for signs of spinning. Has the U-joint bearing cap spun in the ear itself. We don't want that to happen because it can wallow the hole bigger. And there would be circular marks if it had spun. As a matter of fact, Spicer recommends that under no circumstances do you lubricate the outside of the bearing cup or the inside of the ear, the hole here in the ear, when you install a new U-joint, because it can promote the rotation of the bearing cap in the yoke itself. All right, now I've somewhat cleaned up. I'm going to take some brake cleaner and clean it up even better. The major portions of grease from the previous U-joint that are there. But also, I recommend that you get a set of picks and get like a 90-degree pick and get in there, and you need to clean out all of the dirt, grease, anything that is in those snap ring grooves. Because how are we supposed to set the end play of the universal joint and its bearing caps on the thrust end if there's garbage in the grooves that hold the retaining snap rings in place? So you want to get all the rust, corrosion, anything like that out of those bearing caps. So I'm just going to take a little bit of brake clean here. Attempt to clean that up. Clean the bottom one. I want to make sure I don't wash off my alignment marks there, but let's clean all that out really well in preparation for reinstallation or installation of the next universal joint. So let's get it just as good and clean as possible. And remember, as I said in the previous video on inspecting drive shafts, I always recommend replacing all the universal joints on the shaft at the same time, so that there's not any type of imbalance or moments of inertia related issues that can come from having two different weights of universal joints. And you wouldn't think that they would weigh differently, but they do. Get a scale and measure the factory universal joint and then measure the one that you're putting in. Okay, I've got those nice and clean. I don't see any signs of damage that will impact the installation of the universal joint when we go back together. And of course, we want to do the same thing with the steel end of the yoke. We'll push this bearing, or these U-joints bearing cups out, and clean it up and get it ready also. And once again, we are going to have to replace snap rings. The factory U-joint came with two different snap ring thicknesses in it. We are going to have to adjust the lateral play, how much slop up and down there is in the U-joint bearing caps once we get this installed, to make sure that it's not too tight and it's not too loose. Let me finish pressing out the rest of this universal joint, and then I'll clean up this yoke and its ears and snap ring grooves and holes and everything, and get ready to install a new universal joint here. By the way, the plastic injected retainer ring U-joints are pressed out the same way. They do take more effort to press. You got to put almost 100 pounds of force on the Arbor press to pop those plastic retainers, but they just pop right out with no problem at all. As I showed you before, it just shears them right off. You leave the rest of the plastic on the inside of the yoke, or you take it all out. You can't have it one way or the other. You have to either leave it totally in if it's undamaged, or take it out. And normally, if you just press it out like this, you leave the old rest of the plastic in there.